Imagine a distant future when humans reach beyond our pale blue dot, forge cities on planets thousands of light years away, and maintain a galactic web of trade and transport. What would it take for a civilization to make that leap? There are many things to consider. The basic things are like how would we communicate, what might that government look like, and one of the most fundamental of all, where would we get enough energy to power that civilization, its industry, its terraforming operations, and its starships? An astronomer named Nikolai Kardashev proposed a scale to quantify an evolving civilization's increasing energy needs. So, in the first evolutionary stage, which we are currently in, planet based fuel sources like fossil fuels, solar panels, and nuclear power plants are probably enough to settle other planets inside our own solar system, but not much beyond that. For a civilization on the third and final stage, expansion on a galactic scale would require 100 billion times more energy than the full 385 iota joules our sun releases every second. So, barring a breakthrough in exotic physics, there's only one energy that could suffice: a supermassive black hole. Now, I know it's counterintuitive to think of black holes as energy sources, but that's exactly what they are, thanks to their accretion disk, circular, flat structures formed by matter falling into the event horizon. Because of conservation of angular momentum, particles there just don't plummet straight into the black hole. Instead, they slowly spiral, and due to these intense gravitational fields of the black hole, these particles convert their potential energy to kinetic energy as they inch closer to the event horizon. Particle interactions allow for this kinetic energy to be radiated out into space at an astonishing matter to energy efficiency. And this drastically outshines nuclear fission, currently the most efficient, widely available mechanism to extract energy from mass. The key to harnessing this power may lie in a structure devised by physicist Freeman Dyson known as the Dyson sphere. In the 1960s, Dyson proposed that advanced planetary civilizations could engineer an artificial sphere around their main star, capturing all its radiated energy to satisfy their needs. Now, a similar but though more vastly complicated design could theoretically be applied to black holes. In order to produce energy, black holes need to be continuously fed. So we wouldn't want to fully cover it with a sphere. Even if we did, the plasma jets that shoot from the poles of supermassive black holes would blow any structure their way into smithereens. So instead, we might design a sort of a Dyson ring made of a massive remotely controlled collectors. They'd swarm in an orbit around a black hole, perhaps on the plane of its accretion disk, but farther out. These devices could use mirror like panels to transmit the collected energy to a power plant or a battery for storage. We need to ensure that these collectors are built at just the right radius. Too close, they'd melt, and too far, they'd collect very little energy and can be disrupted by stars orbiting the black hole. We would likely need several Earths worth of highly reflective material like hematite to construct the full system, plus a few more dismantled planets to make a legion of construction robots. But once built, the Dyson ring could be a technological masterpiece, powering a civilization spread across every arm of a galaxy. This all might seem wild speculation, and most of it is, but even now in our current energy crisis, we are confronted by the limited resources of our planet. New ways of sustainable energy production will always be our need as technology and science progresses. Well, maybe there is a civilization out there who has already started it. They're not. Or maybe this is supposed to be just in the realm of theory. Only time and science will tell.